In this video, we'll talk about electronegativity. Electronegativity, in a nutshell, is the tendency of an atom to attract shared electrons, which means when an atom is in a bond with another atom, its electronegativity determines how much it pulls in those shared electrons in that bond. And remember that attraction is coming from a Coulomb's law attraction, right? That's electrostatic attraction. Positive and negative attracting. And the positives that are attracting those electrons are from the protons in the nucleus. But if you remember Coulomb's law, the two major important things are not only the charge, but the distance. And there are two competing effects. If you have more protons in the nucleus, there will be a stronger attraction to the electrons. So that's going to make the electronegativity higher, right? It means that that atom will be able to pull electrons in more. But if there's a large distance between the protons of that atom and the shared electrons, that extra distance will actually make that attractive force much weaker. So we have two things going on. As atomic size goes up, your electronegativity goes down. But as your atomic number goes up, which is the number of protons, your electronegativity goes up. And if we think about those two trends in the periodic table, we can make some kind of generalizations. And now remember that the atomic size is really dependent on the highest energy level of the electrons. And as you increase in energy level, you're increasing your distance from the nucleus. So the 1s energy level, or the 1s energy sublevel, versus the 2s, one of the differences is that the 2s is further away on average. So as we go down a column, all we're doing is going from the second to the third to the fourth to the fifth energy level. So the atomic size is getting bigger and bigger and bigger and bigger. However, we're also increasing in atomic number. You're getting more and more and more protons. It so happens that the effect of that increase in size overpowers the increase in charge from more protons. So as you go down a column, even though you're increasing in protons, the increase in distance makes the electronegativity go down. So it's saying that the smaller you are, the higher electronegativity you will have. And again, it's going to go from top to bottom in a column. Now, across a row, you're all in the same energy level, right? These are all in the second energy level. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. And you can see that it's going up now. And that's because they're all in the same energy level, so they're all pretty much the same size, more or less. But as you go across, you're increasing in protons. So your atomic number is increasing. So our two basic trends are, as you go across a row, electronegativity generally increases, and as you go down a column, electronegativity generally decreases. And you can see on this little graph here, the height is representing the electronegativity as well as the color. So these dark kind of purple ones, these are the most electronegative, and these kind of light pink ones are the least electronegative. And then we can come in and get actual values for these. So this is one set of values that you could use. And these values become really important when you determine what kind of bond do we have, right? So if each atom is pulling on the electrons evenly, we would call it a nonpolar covalent bond, right? So all you have to do is get the electronegativity of one atom and subtract it from the electronegativity of the other. And if there's not a large difference in their strength in attracting those electrons, it's called a nonpolar covalent bond, right? It's even. Now, if there's a slight difference, we call it a covalent bond. This covers a wide range of things that are pretty much even to noticeably uneven. But when you get up to a polar covalent bond, they become very clearly uneven, which means that one atom is attracting the electrons much more than the other. And the kind of extreme of this, if there's a large difference in the electronegativity, is it's an ionic bond. They're not even sharing anymore. One atom is basically taking the electrons from the other.